All right, so this is part B. It says a recovery device on the scene arrives on the scene and begins removing oil. The rate at which the oil is removed is R of T equals 400 times the square root of T cubic centimeters per minute, where T is the time in minutes since the device began working. Oil continues to leak at a rate of 2,000 cubic centimeters per minute. Find the time when the oil slick reaches its maximum volume. Justify your answer. Okay, so this is part B. And you have to kind of use your intuition a little bit on this. I'm going to make the cylinder here, our oil spill, look a little bigger than it really is. But if you think of this the spill this way, there's a certain amount of oil going into it, and we know that that's 2,000 centimeters per minute. And remember, we talked about this in the first part. That's constant rate. It's always 2,000 centimeters per minute. It doesn't vary with time. And then this device comes along, starts sucking up the oil, and that's sucking it up at a rate, this is R of T, and that's 400 times the square root of T. So that does vary with time. It increases as time increases. The amount of oil it's removing per minute increases. Okay. Sorry, this is all cubic centimeters. Right? Okay. So when is it going to maximize? What we're looking for when the oil slick reaches its maximum. Well, think of it this way. You've got this. You think of the, volume of oil and the time. What's happening? Well, it starts out there's no oil slick, right? And this oil is going up and up and up at a rate of 2,000 centimeters per minute. At the same time, this guy over here, what am I doing here? This is what I want. This guy, R of T, he's sucking the oil out. So that's like it's decreasing, right? So there's this pulling out. So what is that? When you put those two together, it's probably pulling out at a slightly lower rate at first, but it's getting bigger. Okay, so what's happening? What's really happening with the amount of oil in the cylinder? Well, it starts out and it's filling up and it's filling up, and as over time, right, this R of T is getting bigger and bigger. So it starts out with, at zero, at T equals 0. Well, this is still 2,000. The amount that's coming in is still 2,000 cubic centimeters per minute. But the amount that's coming out at T equals 0 is 0. So there's nothing coming out at that point. Nothing is being removed. After 1 minute, 400 cubic centimeters per minute are coming out. After 2 minutes, well, let's put it this way. After 4 minutes, 400 times 2, 800 cubic centimeters per minute are being removed. So what's happening here is the volume is increasing, it's increasing, and then at some point it starts to decrease, right? And hopefully everything works out for this environment, it actually gets down to 0. Well, what happens right here? What happens when we get to this point where it starts to decrease? That's when R of T has gotten bigger than the amount that's coming in. The amount that's being removed is bigger than the amount that's coming in. Okay, so what we're looking for, this point, this break-even point where we've maxed out the amount of oil, that's going to be when R of T, which we said is 400 times the square root of T, when that is equal to 2,000. When they're equal, any time after that, this one, R of T is going to be bigger than 2,000, right? So this is an increasing function. R of T is increasing for all the positive T, right? As we go along here, it's increasing. So at that point, this R of T is going to be greater, and so the amount of oil that's coming out, it will be greater than the amount of oil going in. So the amount of the total volume of oil will be declining, and we'll have reached the maximum. So now what we have to do is solve this. 400 square root of T equals 2,000. And that's pretty straightforward. So square root of T equals 5. Remember that that means that T equals 25. I saw some people who had T as the square root of 5. It's just a little brain cramp there. So T equals 25. So at 25 seconds, these two, the amount going in and the amount coming out will be equal. They'll be going at equal rates. And so after that, at that point, it will be at its maximum. this cylinder here will be at its maximum volume. After that, it'll be going down. All right, so this is our answer for part B. T equals 25 seconds.